Engineering Technology. I would like to welcome our webinar chief guest, Dr. G. Jagadheeswaran, Professor of Civil Engineering Department in Sona Engineering College. Welcome, sir.
Sir, welcome.
Now, our final year student Deepa will give an introduction about our chief guest. Ms.
A
Deepa, do
warm
you
good morning.
introduce our chief guest?
Yes, sir. Yes, sir.
Okay, ma'am.
A warm good morning to all. I am Deepa. I am very happy to introduce today's chief guest, Dr. D. Jagadheeswaran, sir. He is a professor in Sona College of Technology at Salem. He got BE Civil Engineering at 1994 and ME Structural Engineering at 2006, and he completed his PhD at 2013. He has 5 years of industrial experience, also 5 years teaching experience in Polytechnic College, and 13 years teaching experience in Engineering College. Ultimately, he also has 6 years of research experience. He has published 25 plus papers in national and international journals and conferences. He has one completed and one filled patents. I welcome you, sir. I am so excited for the upcoming today's webinar. I welcome you, sir. Over to the chief guest. Thank you.
Okay, thank you, ma'am. Now we start our presentation. Yeah. I think show my slides.
Yes, sir. Slideshow போடுங்க sir.
Okay.
Now it's okay, sir.
Okay. Okay. Good morning, one and all present here. I am Dr. D.JEGATHEESWARAN, working as a professor, Department of Civil Engineering, Sona College of Technology, Salem. I have present important or popular research areas in the field of civil engineering. Before entering into the topic, we must know about the engineering. Because I believe education is the wonderful travel from known to unknown. Anybody, what is engineering? Or what do you understand about engineering? Now, engineering is the combination of thoughts and approach. That is, application of mathematics and the science. Somebody told that mathematics is one of the science. However, engineering studies, mathematics is a major role compared than science. Therefore, the mathematics act as the major role for calculation of engineering cutoffs. Next question, what is civil engineering? All of you know, the civil engineering is the mother of engineering. It is the first engineering course. What are the focuses? There is the focus areas in civil engineering, or when or where the civil engineering knowledge is applicable. The construction of roads, bridges, dams, pipelines, tunnels, railways, infrastructures, that is buildings, towers, skyscrapers, residential apartments, villas, industrial buildings, factories, stadiums, and petrol bunks, airports, dock and harbor. Everywhere is civil engineering knowledge is applicable. What is research? Next question. The big question is, what is research? All or no, research is the research. Okay. How to bond civil engineering? Any idea? Who is this? Porters. That woman, technically called as a pistis, all are carrying weights or loads on their heads. Why? Because our skull is having high load carrying capacity. So that ideas, that is the shape of the skull, is transferred to our construction domes, dome structures or designing of shell roof structures is based on the skull. Some of the pictures of the dome structures. Next one is saw the film, that is the picture. There is one man carrying a thumbpulls as a horizontal manner. Thumbpulls having less weight, so it's okay. But his weight is heavy means he feel pain at his arm position. So it is the easy example of understanding. Okay, that is the cantilever structures. We support in the restricts the pain, it's called as a proper cantilever structures. Another one, he is the weightlifter. You observe the standing position of the man. He is in a standardized position. It converted into the transmission tunnels. From that, what is your understandings? Our anatomy is the reference to civil engineering structures. Here, bones are considered as reinforcement, and covering muscles of bones is converted as concrete. Now, we focus on our nerve system. What is the function of nerves in our body? Nerve system gives sense to our body. Sometimes it predicts the impacts also. For example, one person threw a stone with the aim for hit your head. Before the stone reaches, our body is automatically flexible. Okay, because of sense. For example, there is a smart buildings or smart sensor buildings. Now it is in a progress in field practical way. Before I entered to the one movie, I think it is a famous one, all are known. That is a flight attack on World Trade Center, New York, on 11th September 2001. Oh, who is the terrorist? It is the Osama bin Laden. He is the successful civil engineering. With the building having sense, how it reflects? If building having sense means okay. These are the thoughts. So research areas in civil engineering, we focus on this one. There are so many research areas. We choose based upon our interest. Okay. Here, this presentation, I am mentioning some of the current research areas. In civil engineering, we focus the research into three ways or three directions. One is the interdisciplinary research, another one is the industrial research, the last one is the advanced research. Okay. So why we step into research? Any necessity? It's needs. Nowadays, a huge amount of waste are accumulated in and around our environment. It creates a lot of problems like pollution, the contamination, disposal problems, etc. So, how to utilize or reuse the waste into the construction industry? Because of scarcity of resource materials, we go to determine remedies or alternatives. Another one is we strengthening the existing structure is one of the need, and also we monitor we monitor the existing structures due to failure or other repair works. But maximum research, that's all based on the solution of, that is the environmental problems. The given structures, that is the given research, is based on the eco-friendly or environment friendly. On the same time, the structure is in a cost effective and also time reducing. That some researches are based on the innovative things, and some research based on the improvement of the performance due to the some certain loads or certain situations. The maximum research is the solution of the problem facing in nowadays is the problem is the COVID. We need some solutions, same type of the solution of the problem facing in and around our society. It is an easy way to understand. It is, you know, that it is the idli. His morning is make the idli. What about the evening? There is the waste. No, it is converted into the some idli upma. That is known as or under the title of utilization of waste. It's not a utilization, that is the reuse or recycling some portions. That is the topic is waste to wealth. Is today the entire globe in research enter into the waste to wealth. So based on the waste, now we focus on hazardous waste management. Hazardous waste is any waste or combination of waste that possesses a substantial danger. Now, in a future, the human, plant or animal life and which therefore cannot be handled or disposed of without special precautions. So the hazards and the disorders can be classified into 4 categories, that is natural events, technological events, man-made events, and the region-wise events. The hazardous waste management involving some procedures, that is the steps. First one is the identification of hazardous waste generation. That is the identifying the hazard waste generating industries is the first step. The hazardous waste are classified under 18 categories, and this information may be used to screen the waste generated and classifying them as hazardous waste. However, there are few observations that there is a probability of occurrence of waste is more than one category, and this classification system does not give any information to understand the toxic characteristics of hazardous waste. The second procedure or second step involved is the data collection. After identifying the hazardous waste generating sources, the inventory of the data pertaining to hazardous waste generation can be developed by conducting surveys through specially prepared questionnaires to each of the identified source. This should be followed by the field visits for data verifications. Third one is the waste characterization. The hazard waste that is generated from the study region should be characterized. For this purpose, it is advisable that the samples may be collected from the waste generation source and analyzed in the laboratory. Literature data may be used in the absence of the primary data. Next, the quantified, that is the hazard waste are quantified based on their individual characteristics. The several options of compatibility of waste with different characteristics should be studied and segregated. The quantity of hazardous waste will be expressed in terms of each category of disposal, that is the recyclable or incinerable or disposal, etc. After quantifying the hazardous waste, the assessing the probable area requirements for its treatment, storage, and disposal. That is the TSDF, shortly mentioned is. For this purpose, topo sheets and remote sensing images of the study regions may be used. The sites are to be physically verified in the field and to draw observation pertaining to the 4 different types of attributes. That is the reciprotor related and path related, waste characteristics related, and waste management practice related. These attributes available for ranking the sites. The site with a minimum score out of the available sites for ranking should be chosen as the site for establishing a treatment, storage, disposal facilities. Next, the important one is the environmental impact assessment should be conducted in the site identified in the above step. The impacts from the project should be identified and the public acceptance should be obtained for clearing the site for treatment, storage, disposal facilities. The last one is the implementing the TSDF programs. The program should be implemented at the final designated site. The site should contain adequate provisions for storage, treatment, and final disposals. Layers for collecting the hazardous waste from the waste generation source should be planned. The site should have the laboratory facilities to monitor the function of, that is, the treatment, storage, disposal facility from time to time. The landfill is the final disposal option in TSDF. The leachate that has percolated should be treated in effluent treatment plant before disposal. Okay. The monitoring of ambient environment qualities and the TSDF performance should be done regularly during the post-closure period of landfill. That is normally in 30 years, is mentioned in a WHO and also PWD. So treatment of hazardous waste. Waste to remain after the implementation of waste minimization must be treated to detoxify and neutralize them. That is the remove the poisons. There are large number of treatment technologies available. That is the biological oxidation, chemical precipitation, oxidation reduction, ion exchange, carbon absorption, that means carbon adsorption, membrane separation, and other new technologies. Next one is the geopolymeric material, that is the building materials by synergetic utilization of industrial waste. This is another portion in our, that is the waste utilization portion. Geopolymers, that is a silico-aluminate material formed through mimicking natural rock forming process. The fast emerging as new class of green building construction materials. For example, the fly ash, blast furnace slag, and red mud are the three major industrial wastes in India. Presently, over 100 million tons of fly ash, 12 million tons of blast furnace slag, and nearly 4 million tons of red muds are generated. It is estimated that production of this waste will double in foreseeable future due to rapid expansion coal-based powder generation and increase in the production of iron and steel and aluminum through primary processing. These waste materials contain silicon dioxide and aluminum dioxide, among with the ferric oxide, calcium oxide, and magnesium, and that materials also, that minerals, and they have immense potential as man-made raw materials for geopolymers. There is a geopolymeric building materials is nowadays is using. Next one is the waste. There is a geopolymerization of waste. Most proposed mechanism of geopolymerization consists of dissolution of aluminosilicate base. That is one is aluminosilicate source is in a dissolution, polymerization and precipitation of gel paste and the transformation of the gel paste into the geopolymer of varying crystality and crystality and the structures. Depending upon the experimental condition, the different stages of geopolymer formation may overlap and even merge with each other. Isothermal conduction calorimetry was used to study the geopolymerization of fly ash, mixture of, that is the fly ash and the GBFS, and the mixture of containing fly ash and furnace slag plus red mud. It's a geopolymer cement. So two different approaches were adopted to enhance the reactivity of fly ash. That is the air classification to separate finer fraction and mechanical activation in attrition and vibratory mills. The small size sensor pair cools faster during the formation in cold compression process, and the separation of finer fraction by air classification results in increase in the glass contents. That is the raw fly ash. Mechanical activation result due to the combined effect of particle breakage and other bulk and surface physicochemical changes induced by the process of milling. These are the geopolymer cements. Next one is the use of industrial waste. That is the synergic use of industrial waste. There is a synergic use of industrial waste is an emerging concept whereby combination of two or more waste is used to develop a useful product. The fly ash used for the development of geopolymer cement. Combination of fly ash and the blast furnace slag was used for self-glassed tiles. On all three waste, fly ash, GPS, and red mud was used for pavement tiles. From the point of view of zero or minimum flow into environment, geopolymer cement is best suited for thermal power plant, where fly ash is the main byproduct. Self-glassed tiles and pavement tiles are more suitable for iron and steel and aluminum respectively. Next one is the alternate building materials. Now the maximum research are going on this title. There is in building construction industry, it has been seen that the materials which were being used about a century back are still very popular. Variety of alternate building materials are available which provide better, efficient, durable, and cost-effective construction, and also ensure judicious utilization of available limited resource with least possible degradation of environment. The demand for building material has been continuously rising with the increasing need for housing both in rural and urban areas. The commercial exploitation of traditional building materials by various industries has aggravated the situation. It has therefore become necessary to think over this problem seriously. Aggravated, that is the to think over this problem seriously and to provide some sustainable solution to make the alternate materials available to solve the housing problem. The government of India is committed to the cause of bringing about rapid and sustainable development in rural as well as urban areas. For example, is bricks, cement, steel, aluminum, plastic products, paints, polished stones, ceramic products are the commonly used materials for construction today. These materials are energy intensive and are transported over large distances before being used for construction. Okay. Regarding the use of modern building materials, the energy consumed in the manufacturing process, that is the energy intensity, problems of long distance transportation, natural resources and raw materials consumed, recycling and safe disposal, impact on environment, and long-term sustainability. Thus, the issues related to energy expenditure, recycling, biodegradable, environmental and sustainable with respect to future demand need to be addressed during the manufacture and use of any new building materials. Okay, next one is the stabilized mud blocks. That is the dense solid blocks compacted using the machines with a mixture of soil, sand, stabilizer, and water. After 28 days curing, the stabilized mud blocks are used for wall construction. There is normally two block sizes are used. There is a standardized one. These blocks are 2.5 to 2.8 times bigger in volume when compared with the locally available conventional burnt clay bricks. The compressive strength of the block greatly depends upon the soil composition, density of the block, and the percentage of stabilizer. Sandy soil with 7% cement can yield blocks having with compressive strength of 3 to 4 Newton per mm square. High strength for the block can be obtained by increasing the quantity of stabilizer. Major advantages are that the stabilized mud blocks are energy efficient, do not require burning. 70% of energy saving when compared to the burnt bricks. Next one is the economical. There is a 20 to 40% saving in cost when compared brick masonry. Plastering can be eliminated and better block finishing. Okay, that is the stabilized building blocks. The maximum the research that is the stabilized mud blocks are in IIC Bangalore. There is a professor, that is a, I think, is former faculty, that is Dr. K.S. Jagadish. He's a famous professor. He's a researcher based on these mud blocks. These are the dense solid blocks, compacted using machine with mixture of soil, sand, stabilizer. Okay, it's a good, great appearance. These buildings are the using the mud blocks. It's a construction building blocks. Next one, that is the alternative material. It is called as a bagasse. Is converted to the cement building boards that is normally used in the roof ceilings portions and also soundproofing material. There is a numerous composites. That is a medium density reconstituted boards. Have already been developed using different natural and synthetic and man-made fibers in polymer matrix. Most of the boards are being used for replacing wood and other conventional reconstituted wood products. Some of these fibers have also been used for making high density fiber board using cement as binder. The development is aimed to develop the building boards and door shutter using bagasse fiber. Building board is suitable for partition, that is the partition wall. We use the partitioning, paneling, etc. The developed product and process are prototype and laboratory level respectively. The physical mechanical behavior of the developed building board passes most of the requirement of general purpose, high density board and cost effective. Next one is the coir and CNSL board. There is a CNSL means cashew nut cell liquid. There is a combination of coir and cashew nut cell liquid. Is a wood alternative which can be used for surfacing door and window shutters, partitioning, false ceiling, paneling, furniture, cabinets, packages. A lot of materials are now available using our places. It is a single layer flat pressed glass medium density fiber board. It has a low water absorption, negligible change in dimension due to water absorption, workable with the normal woodworking tools, paintable, pre-laminable, nailable, and screwable, and also it is passes IS 30874. The board is eco-friendly and can replace wood or reconstituted wood by 100%. The next one is the lightweight sandwich panels. The cellulose refuse of paper industries are rich in small fibers and can be used to make value-added product. It is the lightweight sandwich panels and also the paper kit bricks. They both are mixed in the wood cellulose materials, which can be used for acoustic, thermal insulation, and false ceiling purpose in buildings. The laboratory scale developed technology yielded a lightweight sandwich panel, which is very much suitable for above mentioned purposes. These developed panels have their end application is partitioning, paneling, thermal insulation, and false ceiling with its unique aesthetics view also. The technology as well as product has been patented. The estimated economic viable capacity is 2 tons per day and most suitable for paper industries as a downstream process. Next one is the fine concrete blocks. Is another material, that is the alternate material. That concept and the process is similar to that one employed for, that is a stabilized mud bricks. That is the same production except that instead of soil, some fines are added to the mix. Fines like fly ash, polished stone waste, etc. These are mixed with either sand or stone quarry dust along with the cement and water. The mixture is then compacted into blocks using a machine and then cured for 28 days. Fines, that is the fly ash, polished stone waste, that is the fines, in the range of 20 to 25% by weight of sand can result in a good grading for the mixture, and with 6 to 7% cement, good quality block with wet strength, that is the greater than 3 megapascal can be achieved. In addition to fines, about 10% of red loomy soil addition can result in good natural mud color for the block. The major advantages of fine concrete block is the utilization of waste products like fly ash, polished stone waste, mine waste, etc., which otherwise cause pollution and environmental degradation, and also the where is the dumped. That is one of the problems. Next one is the steam cured blocks. The mixture of lime, industrial waste products like fly ash or expensive soils like black cotton soil and sand can be compacted into a high density block. Lime reacts with fly ash or clay minerals, forming water insoluble bonds, imparting strength to the block. These reactions are slow at the ambient temperature, that is the near to, I think, 30 degrees Celsius, and hence steam curing for about 10 hours at 80 degrees Celsius can accelerate this reaction, leading to high strength for the block. Some causes of poor acceptability and of alternative building materials is the lack of knowledge about new materials, non-inclusion in various national codes and specifications, inappropriate environment for research and development, non-availability of proper forum for promoting new materials, ineffective and improper publicity, unawareness among users, poor competition among new materials manufacturers, higher price structure of new materials, and lower emphasis on research on eco-friendly materials. Another one thing is the negative attitude of engineers or architects towards non-scheduled items, lower confidence on quality. That another one is the negligible technological thrust for wider acceptance and adoption. These are the causes of poor acceptability of alternative building materials. Next one is the alternative sand. Normally we use the M sand, that is the manufactured sand, is the term used for aggregate materials less than 4.75 mm and which are processed from crushed rock or gravel. Due to booming of construction activities in our country, natural sand resources are increasingly depleted and its cost is becoming increasingly high. Therefore, I conducted to study the influence of the manufactured sand is in the having the high compressive strength, and also these ones. The cost comparisons results also have shown that using manufactured sand in partial or full replacement to natural sand does not cause any significant cost variation. It has been found also that use of manufactured sand is more suitable for high strength concrete production. It can therefore, we conclude that when the availability of natural sand is scarce or in cities where the price of natural sand is as expensive as manufactured sand concrete mix is a viable and better alternative to the use of natural sand. Another is the volcanic glass, is the amorphous product of rapidly cooling magma. Volcanic ash and lava also form rich soil. While hot rocks heat under water, volcanic ash also serve as a natural resource for construction and industry.
Professor, sorry for the disturbance.
Yes.
Sir, your screen is not visualized, Professor. PowerPoint screen.
Oh. So now itself for a long time.
No, just a few minutes back, Professor. 1 or 4 or 5 minutes.
Sir, you.
Otherwise,
Sir.
It is okay.
Is it okay, sir?
Okay,
sir.
Okay. Right. That automatically is on screen is shut down. I think it's a setting time. Okay. Next one is the lightweight concrete. We already know the lightweight concrete. What is the that is the weight ranges. It is normally now our India is somewhat new one, but the US countries the more than 50 years we use this. The compressive strength is not as great as ordinary concrete, but it weathers just as well. Among its advantages are less need for structural steel reinforcement, smaller foundation requirements, better fire resistance, and most importantly, the fact that it can serve as an insulation material. It can cost more than sand and gravel, and it may shrink more upon drying. Lightweight concrete may be made of using lightweight aggregates or by the use of foaming agent such as aluminum powder. The normally used is the foam concrete material, that is which generates gas while the concrete is still plastic. Natural lightweight aggregates introduce, that is Pimucas, Coria, volcanic linters, tuff and diatomite. These are used in this one. The lightweight aggregates can also be produced by heating clay, shale, slate, and perlite. Furnace slag that has been specially cooled can also be used. Next, pumice screech, another one. It is an extremely lightweight rock formed when volcanic lava cools so quickly that most of its volume is comprised of teeny bubbles of trapped gas. Pumice is made up of three ingredients. That is, pumice as aggregate and just enough Portland cement and water to hold the pieces of pumice together. The insulating value of pumice comes from both the tiny bubbles within the sponge-like pumice itself and the larger air spaces between the pumice pieces. Once the whole wall is sealed by the plaster coating, pumice is poured into the forms to cast walls in place. Then a solid concrete bond beam is poured atop the wall to hold connectors for the roof system. With the minimal wall thickness at least 14 inches, pumice is strong enough to need no additional structural support for most 1 or 2 story buildings. Somewhat having some advantages like that is can be delivered pre-mixed in trucks or mixed on site, and like wood, the pumice will not burn, rot, or get eaten. The uniformly coarse pumice surface allows a stucco finish without the use of stucco emitting, and the lightweight of pumice allows the use of lightweight forms made of half-inch plywood, and there is the 2x4 size, that is 2 feet and 4 feet size, that can be saved for use of another building projects. Is much more consistently insulated than conventional stud and back walls, and they allow for less air infiltration.
Sir, sorry for the intermission, sir. Once again,
Yes.
sir.
Sir,
the screen is not visualized again.
Sir, it is visible
PPT.
for me. So PPT is visible for me. So this problem is for
all the participants. All the participant PPTs are visualized or not? All the participants, please kindly listen.
Sir,
PPT or visualized?
Sir, visible, sir. There are 2 names in Dr. D.JEGATHEESWARAN name. You can pin one of the name, then visible, sir.
Okay.
There are 2 names in Dr. D.JEGATHEESWARAN. You can pin one of the name. Then only visible, sir.
Okay.
Is no problem, sir. Now it is okay.
Okay, sir. All the participants use the another Dr. Jagadeeswaran ID. Thank you, sir.
Okay. Oh, some Google meeting, some problems. The pin panunala. Yes, now it's a pin. Next one is the mortarless system. That is the interlocking system. The demand of houses for low to medium income population of the world has exceeded more with the increase of construction material costs such as cement, steel, and timber. Contractors are not enthusiastic to build these houses on a tight budget. But the mortarless system is normally in developing countries, masonry performs simultaneous functions of carrying load and enclosing space while possessing strong properties of fire resistance, thermal and sound insulation, and protection against environmental exposures. As a result, masonry is a cost-effective and low-energy alternative when designed appropriately. However, its main shortcoming is that its construction is slow and labor-intensive. Furthermore, conventional masonry construction, especially for smaller units, leads to larger number of mortar joints. In order to limit the stress induced in these joints during construction, the rate at which the height of a wall increases is somewhat restricted. Now, the interlocking blocks are different from conventional bricks since they do not require mortar to be laid during bricklaying work. Because of these characteristics, the process of building walls is faster and requires less skilled labor as the blocks are laid dry and locked into place. The concrete blocks may be produced with hollow centers to reduce weight, avoid seepages, or improve insulation. Is one of the meanings the improve, but it is the older technology. So now it is using the interlocking, but the maximum portions of the older days already constructed some buildings. The holes inside the concrete block allow rebar and concreting to run vertically through the block to compensate for the lack of tensile strength. Rebar used can be of mild steel instead of the usual higher grade steel. Once a section of wall is built, grout holes are filled with a lean cement mixture to seal the wall and making a permanent solid wall. The amount of grout used was calculated to be less than 7.5% of the mortar used in the conventional masonry. It is based on research. It is somewhat less, it is less than 8%. The interlocking bricks, that is a mortarless system, is for purpose to reduce the weight of the block and to insert steel rods or treated niche bar for reinforcement, act as a conduit for electrical and water piping. The last one is the pour liquid mortar into the holes which run through the full height of the wall, thus increasing stability and providing barrier to seepages. Some the classifications of the mortarless system. Now, the based on one is the geometry and interlocking system. Geometry having the solid and the hollow. Interlocking, geometric and non-geometric is a proto ring and a dovetail. Next one is the tongue and the groove and bed of head joints. That is a grout and the surface bond. There is a FRP used in this mortarless masonry. Other types also use. There is a Hainer block and Azar block and the Sparlock block, I think. These are these. But what is the advantages of the mortarless masonry? Blocks can be laid much easier with less technical skill. Decreased risk of moisture. There is a decrease of moisture damages and shrinkages. More stability during construction compared with the conventional masonry because the blocks do not swim in mortar. Walls can be loaded immediately after construction. Masonry can be assembled in any weather conditions. These are the advantages. Some having some limitations also for the mortarless. Mortarless, the unit is a mortarless construction work. Relatively high initial settlement. There is another disadvantage is the challenges in controlling the height of the units to achieve accurate running bond. Another difficulty in keeping grooves from breaking during transportation and construction. And in running bond pattern, plain interlocking units without grouting have little resistance to vertical bending. Another one disadvantage is the stack bond pattern. Plain interlocking units without grouting have little resistance to horizontal bending. That is the one. Another one is the high performance concrete. It's already it is a maximum civil engineers knows because the high performance portion is in our textbook, concrete technology book, and also the construction materials and practices books. Now we know the concrete is considered as a durable and strong material. Reinforced concrete is one of the most popular material used for construction around the world. Reinforced concrete is exposed to deterioration in some regions, especially in coastal regions. Therefore, researchers around the world are directing their efforts towards developing a new material to overcome this problem. That is the performance needed. That is the performance needed concrete. The ACI defines the high performance concrete is as concrete which meets special performance and uniformity requirements that cannot always be achieved routinely by using only conventional materials and the nominal mixing, placing, and curing practices. The performance may involve enhancement of characteristics such as placement and compaction without segregation, long-term mechanical properties, and early age strength or service life in severe environments. High performance in a broad manner can be related to any property of concrete. In the high performance concrete, we know a lot of characteristics. We know that it is a high strength, high early strength, high modulus of elasticity, high abrasion, but the needed positions, that is the where it is located and where it is the concrete is pouring, that places having some performance. So it's a tailor-made concrete. There is a high performance concrete is tailor-made concrete. The lot of advantages: reduction in member size, resulting in increase in plinth area or usable area, and direct savings in the concrete volume saved. That is a reduction in the self-weight and the superimposed dead load, a reduction in formwork area and cost with accompanying reduction in shoring and stripping time due to high early age gain in strength, and longer spans for fewer beams for the same magnitude of loading, reduced axial shortening, smaller depreciation as a fixed cost, reduced maintenance and repairs, lot of advantages. Some little limitations also there. That one is the high performance concrete has to be manufactured and placed much more carefully than normal concrete. Is the very care is needed. Another, an extended quality control is required. In concrete plant and the delivery site, additional tests are required. This increases the cost. Some special constituents are required which may not be available in the ready-mix concrete plants. These are some limitations. Next one is the green concrete. This is a revolutionary topic in the history of concrete industry. This was the first invented in Denmark in the year 1998. The green concrete is very often also cheap to produce because, for example, waste products are used as a partial substitute for cement or other materials. Charges for the disposal of waste are avoided. Energy consumption in production is lower, and durability is greater. Green concrete is a type of concrete which resembles the conventional concrete, but the production or usage of such concrete requires minimum amount of energy and causes least harm to the environment. The carbon dioxide emission related to concrete production, inclusive of cement production, is in between the 0.1 to 0.2 ton per ton of produced concrete. Green concrete has nothing to do with color. It is a concept of thinking environment into concrete, considering aspects from raw materials manufacture over mixture design to structural design, construction, and service life. And also the green concrete is expected to fulfill with the reduction of carbon dioxide emissions by 21%. This is in accordance with the Kyoto Protocol of 1997. Increase the use of inorganic residual products from industries other than the concrete industry by approximately 20%. Reduce the use of fossil fuels by increasing the use of waste derived fuels in the cement industry. The recycling capacity of the green concrete must not be less compared to existing concrete types. The production and the use of green concrete must not deteriorate the working environment, and the structures do not impose much harm to the environment during the service life. These are the some process. There is a conventional concrete, conventional cement, and fly ash. These are the some residual products from the other industries. There is a manufacture of the concrete. There is the green concrete means. Is a lot of advantages over the conventional concrete. It uses the recycled aggregates and the material. It reduces the extra load in landfills and mitigates the wastages of aggregates. Normal the green concrete, the recycled aggregate and demolished aggregates are used. This one. The net carbon dioxide emissions are reduced. The reuse of metals also contributes intensively to economy. It also helps the green buildings achieve the LEED and the Golden Globe certifications. Use of fly ash in the concrete also increases its workability and many other properties like durability to an appreciable extent. Other advantages also, there is a low production cost as waste directly substitute the concrete, and helps in recycling industry waste. Reduce the consumption of cement overall, better workability, greater strength and durability than normal concrete, and compressive strength and flexural behavior is fairly equal to that of the conventional one. Green concrete might solve some of the society's problems. That is the use of the inorganic residual products which should be otherwise to capacity. Next one is the bendable concrete. Is one of the research areas some researchers are doing under the category of bendable concrete. That is engineered cementitious composites, that is ECC in class of ultra ductile fiber reinforced cementitious composites, characterized by high ductility and tight crack with control. Normally, the conventional concrete are almost unbendable and have a strain capacity of only 0.1%, making them highly brittle and rigid. This lack of bendability is a major cause of failure under strain and has been a pushing factor in the development of an elegant material, namely bendable concrete. The bendable concrete is reinforced with micro-mechanically designed polymer fibers. That is, engineered cementitious composite is made from the same basic ingredients as conventional concrete, but with the addition of high-range water-reducing agent is required to impart good workability. However, coarse aggregate are not used in, that is, the engineered cementitious composites. The powder content of, that is, a cement composite is relatively high. Cementitious materials such as fly ash, silica fume, blast furnace slag, silica fume may be used in addition to cement to increase the paste content. Additionally, that is, engineered cementitious composites uses low amounts, typically 2% by volume, of short discontinuous fibers, and super fine silica sand and tiny polyvinyl alcohol fibers covered with a very thin slick coating. The surface coating allows the fiber to begin slipping when they are overloaded, so they are not fracturing. That is one of the idea for the bendable concrete. So the picture, it prevents the fiber from rupturing, which would lead to large cracking. Thus, an engineering cement composites deforms much more than a normal concrete, but without fracturing. That figures represents the behavior of the engineering cementitious compounds under flexural loading, and it can be seen that the beam can deform. Beam can deform well without direct failure. The different ingredients of these ingredients work together to share the applied load. That engineered composites, that is, the cementitious composites, has proved to be 50 times more flexible than traditional concrete and 40 times lighter. Is based on the results are based on some researchers. And also that is the bacterial concrete. Nowadays the research is maximum research is going on this title, the bacterial concrete or self-healing concrete, but not the research ideas into the practical life. The novel technique is remediating the cracks and the fissures in concrete by utilizing microbiologically induced calcite precipitation is discussed. Microbiologically induced calcite precipitation is a technique that comes under a broader category of science called biomineralization. So, nowadays the used is the bacillus group of bacteria used this one. It can induce the precipitation of calcite as a microbial sealant, that a calcium carbonate exhibited its positive potential in selectively consolidating simulated fractures and surface fissures in granites and in the consolidation of sand. Okay. The technique can be used to improve the compressive strength and the stiffness of cracked concrete specimens. A durability study on concrete beams treated with bacteria exposed to alkaline, sulfate, and pre-thaw environments were also the research is doing on. The effect of different concentrations of bacteria on the durability of concrete was also studied. It was found all the beams with the bacteria performed better than that is the conventional, that is the control sections without the bacteria. But this is the one of the important is after casting, now we determine our finding the bacteria is a survival in concrete or not. That is the one major problem in this bacterial concrete. Durability performance increased with the increase in the concentration of bacteria. So microbial calcite precipitation was quantified with the X-ray diffraction test. There is the XR test and visualized by SIM and the morphology tests. These are the proof of the concrete that the bacteria is survival in the concrete. The calcite layer improves the impermeability of the specimen, thus increasing its resistance to alkaline, sulfate, and freeze-thaw attack. And also, in bacterial concrete, one buffer solutions are added because normally the maximum researchers are a failure due to the bacteria is directly mixed with the concrete. At the time, the concrete having the pH value and the bacterial pH value is not matched. So the maximum bacteria are not survival in the type of concrete. So before into the what is the medium materials, we choose some the medium materials, that is the buffer solutions are created. It is the not only the civil engineering only, there is the biotechnology or microbial some departments also helping this one. There is a interdisciplinary research into the category. Another one is the transparent concrete. Nowadays these are the transparent concretes. Is a lot of people are hear the word. The transparent concrete mainly focuses on transparency, and its objective of application pertains to green technology and aesthetic finish. It is the combination of optical fibers and fine concrete. At present, green structures focus greatly on saving energy with the indoor thermal system. Therefore, it is the imperative to develop a new functional material to satisfy the structure in terms of safety monitoring, environmental protection, and energy saving, and artistic modeling. But the concrete has been used in since Roman times for the development of infrastructure and housing. Is a basic components has remained the same. That is, another one is the newly added into the fibers in this concrete. That is the transparent concrete. This in 1960s is open, but since this time concrete has made considerable progress, not only in technical terms but also in aesthetics terms. The concrete has learned to adapt to almost all new challenges that appeared in 2001. So the time the research that is on this transparent concrete. That is some fibers. Normally they use the ingredients are same, the cement, fine aggregate, coarse aggregate, but newly added as the optical fiber elements. That is the optical fiber elements is the elements is one of the difficult means the creating the molds. Normally the transparent concrete is the factory made concrete. Is not in a there is somewhat difficulties in this used in the cast in situ. These applications are illuminate your walls. Our walls are illuminate, and as a payment shine at sunset, creative design, and the artsy reception desk, and also the lighting fixture and conversational piece. It also applicable to the transparent concrete blocks suitable for floors, pavements, and load-bearing walls. Facade material is used as a facade material, that is the interior wall cladding and dividing walls based on thin panels. Partition wall, and it can be used where the sunlight does not reach properly. In furniture for the decorative and aesthetic purpose. Light fixtures, that is the light sidewalks at night, illuminating speed bumps on roadways at night. These are the some uses or applications. Some advantages also this one, that is the very good architectural properties for giving good aesthetical view to the building. Where light is not able to come properly at the place, transparent concrete can be used. Energy saving can be done by utilization of transparent concrete in building because of the lighting. We use the electrical energy somewhat less. Totally environment friendly because of its light transmitting characteristics, so energy consumption can be reduced. The main advantage of this product is that a large scale object, the texture is still visible, while the texture of the finer translucent concrete becomes indistinct and distant. And also is having some constraints. There is a main disadvantage is this concrete is very costly because of the optical fiber. The cost of the fiber is somewhat increasing compared than other gray ingredients. Next one is the casting of transparent concrete block is difficult for the labor, so special skilled person is required. Okay. Okay, I think somewhat both a lot of things we based on the some text. So now the time for refresh. Now is the refresh means research the answer. Some questions. Audience, be ready. What will replace the question mark? 1 is 314, 2 is 325, 3 is 538, 4 is 448, then 6 is anybody's answer. That is the refreshing time. We continuously talking about the concept. We are some boring. Anybody's answers? Okay, this is the one of the research, because first we finding the one. This is a three letters ONE, three letters. That is the first number is 3, but 1 means 1. 4 means 3 plus 1 is 4. Same thought is 2 is the three letter word TWO. That is the 2 is the Roman letter. That's a 2 is the numerical value, and the 3 plus 2 is the 5. Same, that is the 6 is. That is the first one is the 3. Another one is the 6. Another one is the 3 plus 6 is the 9. That is the 369 is the answer. Next, it is some of the mathematical helps, because that is the blue balloon is called as A, and the green is the B, and the yellow is the C. So A plus B is 10, and the C plus C is equal to 8, and C plus B is equal to 5. What is the A? What is B? What is C? That is the question. Anybody's answer? Any audience? I think it is not in our portions, but intermediate he is some bore. So somebody's are step into the sleeping. So avoid that one.
Sir,
Yes,
sir,
yes.
green balloon is 1 rupee.
Green balloon is 1, right?
Okay,
Yellow
sir.
is
And yellow is 4, sir.
4. So automatically B is
Blue is 6, sir.
I think 9. I think that is the first one is
9. Yes,
green.
9, sir. 9, sir.
Okay, right, okay. Another, that is one of the thinking, even and odd. We know odd, the summation of two odds is the even. Summation of odd and even is the odd. So we know that. Same, what is B? Technically, the percentage is called as a brainstorming session. This right? There is a B is odd or even. So a lot of thinking. Okay. So B is even. Okay. Let us some just is questions from WhatsApp. A lot of WhatsApps are there. A rich man needs dash. A poor man has dash. If you eat dash, you die. And when you die, you can take dash with you. What is the word? The one word fits all blank spaces. It's a 7-letter word. Any idea? Okay, the word is nothing. Okay. Is the question who declared corona as a pandemic? The question itself answer. Who? There is a World Health Organization declared corona as a pandemic. Which letter replaces the question?
Which?
Yes. Yes, ma'am.
Sir, it is which?
H. How?
If we remove the word, we'll be getting the answer, right? We'll be replacing it.
Okay. But the concept is they add the 3 numbers, 6 plus 4 plus 4, that is the 14. The 14th alphabet is N. Okay. Next one is the 4 plus 1, 5 plus 7 is the 12. 12th letter is L. Simultaneously, there is a 17th letter, that is a 14 plus 2 plus 1. That is a 17th letter is it's a Q. Okay. It takes some time. Okay. That is some observation questions. Which picture cube does this shape make? Any ideas? You have to in nearly 10 concrete areas. So, okay, you think that is the correct answer is B. Yeah, that is the B. Is the same one because this shed is not here, this is not here, and this is not this one. The same. The shed is opposite one. So this is okay. Okay. Now we go to the terrace garden or is roof garden. Is the research the because the olden ages, that is the Babylon, having same terrace gardens. For example, this one, the section drawing of the hanging garden of Babylon in 500 BC. This is one of the research area because some difficulties, some what is the layer between the roof and the garden having is a two types. The factors which make the roof gardens important part of architecture throughout the world is full use of terrace, which is normally a discarded area in crowded cities, maximum meaningful use of minimum available space, an economical way of balancing green space with uncontrolled growth of cement structures in urban areas. And also they provide additional insulation to building. The trend of terrace garden is not new. For centuries, it has been common to using rooftops as a living space or recreational space in Mesopotamia. That is the world historical space. There is a hanging garden, it's a roof garden. Civilization in Mesopotamia built roof gardens thousands of years ago on the landing of ziggurats or stepped pyramids. What is terrace garden? Is a garden which is established on a terrace, roof, or portico, usually in a house where there is limited gardening space. These type of terrace gardens are especially popular in urban areas. Terrace gardens are commonly created at three different levels, which are one is the on roof-topping of a building, another one is the at the podium level around the base or on roof of large basement, and another one is the introduction of vegetation, greenery in the urban fabric may help to relieve the ill effects of urban heat island effects. That is the heat island effects. The major reason for the to the terrace garden is the contribution they make to the building insulation and the energy savings. This is the evaporations. There is the temperature goes. Normally, the living human is feel comfortably because of this heat island effect in urban areas. Okay. I'm going to next one because he has a lot of ideas, but time is going up. The monolithic dome is first we use it as a dome structure or shell roof structure. Same as that is the modification of the shell roof structure is the monolithic dome. Dome is an element of architecture that resembles a hollow upper half of a sphere. Dome structures made of various materials have a long architectural lineage extending into prehistory. It may be defined as a thin shell generated by the revolution of a regular curve about one of its axes. The shape of the dome depends upon the type of the curve and the direction of the axis of revolution. When the segment of a regular curve resolves about its vertical diameter, a spherical dome is obtained. The domes are used in variety of structures, such as roof of circular areas, circular tanks, exhibition halls, auditorium, bottom of tanks, and bunkers. The energy saving features of domes are summarized by an architect who states, dome embody the virtues of simplicity, economy, and energy conservation, and enclose the maximum amount of space with the least surface area. It is the surface area which consists of building materials and comprises the exterior skin of the building through which heat is gained or lost. This is the essence of dome efficiency. There is the famous architecture is told that one. Is nowadays some areas some hot climated areas is recommended this type of monolithic dome structures. Next one is the bubble deck slab. This also is in now is in practical also. Some knowledge gap is here that the bubble deck slab that research is going on. Bubble deck slab is a biaxial hollow core slab invented in Denmark. That is the one picture you saw. There is a construction of bubble decks. These are the some structural. There is a stadium structures using the bubble deck structures. The bubble deck slab is a method of virtually eliminating all concrete from the middle of a floor slab, which is not performing any structural function, thereby dramatically reducing structural dead weight. High density, that is a high density polyethylene hollow spheres replace the ineffective concrete in the center of the slab, thus decreasing the dead weight and increasing the efficiency of the floor. By introducing the gaps leads to 30 to 50% lighter slab, which reduces the loads on a columns, walls, and the foundation, and of course of the entire building. For example, this one, that is the stress strain diagram. That is the stress diagram of bubble deck slab. So compression is here. The portions, that is the below the neutral axis portions, having some gap that filled with the bubbles. Because it's a biaxial hollow core slab invented in Denmark, it is a method of virtually eliminating all concrete from the middle of a floor slab, not performing any structural functions. Okay. Some stories from the manufacturer, that is the slab, bubble deck slabs manufacturer, told that the bubble deck slab can reduce total project cost by 3%. Bubble deck slab is a new, innovative, and sustainable floor system to be used as a self-support, that is a self-supporting concrete floor. The application of the bubble deck slab, there is a floor system in the Netherlands, is manifested as the worldwide first application. A bubble deck slab floor is a flat slab floor, therefore without beams and column heads. The principal characteristics is that hollow plastic spheres are incorporated in the floor, clamped in a factory-made reinforcement structures. This reinforcement structure consists at the same time of upper and lower reinforcement of the concrete floor. Normally is the standard dimensions are there. Next one is the submerged floating tunnels. Nowadays, our that is the area occupancy area is somewhat reducing. So we also capture the water bodies. So submerged floating tunnels concept was first conceived at the beginning of the century, but no actual project was undertaken until recently. As the needs of society for regional growth and the protection of the environment have assumed increased importance. In this wider context, the submerged floating tunnel offers new opportunities. For example, these are the some pictorial representation for the submerged floating tunnels. It is an innovative concept for crossing waterways, utilizing the law of buoyancy. That is the buoyancy forces to support the structure at a moderate and convenient depth. The submerged floating tunnel is a tube-like structure made up of steel and concrete, utilizing the law of buoyancy. It's supported on columns or held in place by teethers attached to the sea floor or the pontoons floating on the surface. Because of the knowing the place, there's a tunnels having. So no more traffic, that is the navigation traffic is a disturbance the tunnels. The submerged floating tunnels utilize lakes and waterways to carry traffic underwater and on to the other side, where it can be conveniently linked to the rural network to the underground infrastructure of modern cities. These are the connections. The next research area is in the intelligent transport system. That is, the intelligent transport system is nowadays used in the very developed countries. It represents a major transition in transportation on many dimensions. That is, the intelligent transport system is an international program intended to improve the efficiency and the efficiency of surface transport system through the advanced technology and information system. Because all are in digitally, so the picture shows the ITS, that is Intelligent Transfer Systems. It takes the first step towards meeting this challenge by providing effective, reliable, and meaningful knowledge to motorists in times. Problems like high traffic congestion, low transportation efficiency, low safety, and endangered environment can be solved through innovative and sophisticated ways of handling latest techniques that have emerged in recent years in integrating information technology. That are the electronics and the telecommunication with the roads and traffic management, the intelligence system, transport systems are encompasses a broad range of wireless and wireline communication based information control and the electronic technologies. It's based on all our digital and communication level of traffic. Next one is the diagrid. Diagrid is the design and construction of artificial infrastructures on the lines of biomimicking principles require the development of highly advanced structural system which has the quality of aesthetic expression, structural efficiency, and most importantly geometric versatility. Diagrids the latest imitation of tubular structures. They have an optimum combination of the above quality. Some pictures, there is a photographs for the diagrid structures. Diagrids are perimeter structural configurations characterized by a narrow grid of diagonal members. The maximum the structure is in a diagonal one. There is a bracing systems. The diagonal members which are involved both in gravity and in lateral load resistance. Diagonalized applications of structural steel members for providing efficient solutions both in terms of strength and stiffness are not new. However, nowadays a renewed interest in and a widespread application of diagrid is registered with reference to large span and high-rise buildings, particularly when they are characterized by a complex geometrics and curved shapes, sometimes by completely free forms. That is the materials are used for this one. There is a diagrams ones, unit weight of the materials, availability of the materials, lead time. These are the selection, the material selection based on this one. Another one is the another conditions that is for the selection of materials based on the erection time, flexibility, durability, labor cost, fire resistance. These are normally the steel wide flanges are used this one, and rectangular and round HSS that is the sections used, hot rolled steel sections that is are used, and precast concrete. Sometimes the cast in situ concretes are used in this one. So there's some earthquake areas used in the timber, but is in a least popular material for diagrid structures. So it is already used in the some village sites, and also the portions that is the earthquake affected portions. Japan related buildings are based on this. There is a diagrid structures. The advantages is the multi-panel sections can reduce the erection time of labor cost. That constraint is some cost, both for material and connections, are much higher than the traditional structural members of steel and concrete. Okay, that's one. Next one is the demolition. This one, yes, a lot of people is thinking that the demolition is one of the research area. Yes, nowadays the demolition is one of the research area. Because the demolition is without disturbing surroundings is one of the desirable thought for clients. So various steps involved before the demolition process include surveying, removal of hazardous material, preparation of demolition plan, stability report, and the precautionary safety measures to be taken. That is the pro activities for the demolition of building. The main equipment used for this demolition activities as sledgehammer, excavators, bulldozers, wrecking balls, main explosive used for dynamics and RDX. When explosives are used for demolition, it is known as the impulsion. It is called as a impulsion. But some safety measures are taken. Some safety measures are taken. The demolition workers, including plant or equipment operators, will go through the proper job safety training and to be informed for the potential hazards by attending training sessions as well as on the job training. At present, the Construction Industry Training Authority has that organized relevant training courses for site supervisors and foremen and the plant or equipment operators. For there is a safety precautions. That is how to demolish with the safety ground. Okay. Next one is the nanotechnology in construction engineering. This is one of the booming. That is the nanotechnology. We already know that is a nano. That is a 10 to the power minus 9. There is a very fine materials are used in this one. Viewed from the bottom of the concrete at the nanoscale is a composite of a molecular assemblies, surfaces, and a chemical bonds that interact through the local chemical reaction, intermolecule forces, and intraphase diffusion. There is a property characterizing the scale or molecule structure, surface functional groups, and bond strength and density. The structure of the amorphous and the crystalline phases and of the interface boundaries originates from the scale. Properties and the process at the nanoscale define the interaction that occur between the particle and the phases at the microscale and the effects of working loads and the surrounding environment at the macro scale. There is a process occurring at the nanoscale ultimately affect the engineering properties and the performance of the bulk material. But the nanotechnology in construction engineering is now in a research, not in a practical way. The lot of work is doing on that one, but it is not, there is outcomes, the research outcomes is not on the tables. Some a lot of works is in going in the research. Next one is the remote sensing. Remote sensing, all of known, is one of our engineering subject is remote sensing. There is a sensing the material or sensing the functions with remote, with there is a remote conditions. Some examples for remote sensing is the cameras on satellite and the airplanes take image of large areas on the earth surface, allowing us to see much more than we can standing on the ground. Sonar system on ships can be used to create images of the ocean floor without needing to travel to the bottom of the ocean. Cameras on satellites can be used to make images of temperature changes in the ocean. There is a climatic changing conditions. And some specific use of the remote sense is the images of the earth include the large forest fires can be mapped from space, allowing rangers to see a much larger area than from the ground. Next one is the tracking clouds to help predict the weather or watching erupting volcanoes and help watching for dust storms. Tracking the growth of a city and the changes in farmland and the forest over several years or decades. That is the there is a has to changing. So changing in the some decades. And the discovery and mapping of the rugged topography of the ocean floor and magnetic stripping on the ocean floors. That is a remote sensing is one of the research area and the research tool for using the some surface and under the surface areas. Yes. And next is a booming one is the Internet of Things in civil engineering. It is the branch of information technology. Nowadays, the research is not doing the one separate branch, is including the 2 or 3 branches. That is a intra-department works. That is interdisciplinary research. IoT is the branch of information technology which generates a connectivity link between the internet and the actual physical things. This study provides future scenarios of Internet of Things technology and also to simplify the knowledge about the various applications in civil engineering projects. And is more advanced because there is the civil engineering fields, no exception, and will be active around the world by 2020. The adoption is certainty ramping up, and the technologies that support IoT are also growing more sophisticated, including big data, cloud computing, and machine learning. So, ultimately, IoT can measure and identify public roadways that need servicing. These 2 basic examples provide a glimpse into the IoT can do the civil engineering sector. That is alongside That is the other innovative construction technology will completely transform the industry. That said, the role is it currently playing in the field? What are some other applications that are either planned or now in use? How can the civil engineering industry jointly with the IT that is allow the transformation from reactionary and preventive maintenance? That is IoT is normally used in the monitoring the structure. There is the existing structures. Health monitoring is one of the major role in civil engineering. That is IoT is used. The sensors are used in this place. That is a before entering into the topics that we used one. There is a WTC World Trade Center. That building is somewhat reflects the hits. That is based on the some IoT. That is the sensors are fixing the particular buildings. That building is reflects same as our nerve system. Okay. Next one is the drone surveying. Drone surveying is the one of the interesting and very useful is a tool that increasing communication between construction participants, impression site. And it's not only in the civil engineering field, it's a lot of field. That the agriculture field, that is the pouring the fertilizers to the ground in the dense forest. We used to what about the that is the cultivation process is ready or not. These are the using the drone survey. Drone survey is a lot of advantages in civil engineering. That is the construction participants improve the site safety, uses topographic measurement of large areas. With using principles of aerial photogrammetry, it is possible to create buildings aerial surveying, bridges, roads, highways. That is a maintenance works. There is unmanned aerial vehicles, that is a UAV, including drones, provide invaluable help and the cost savings with wide views of inaccessible and otherwise difficult and tough to navigate locations. It sends back a full image of the territory to teams planning logistics for next steps. The drone surveying is next development of the drone survey is in the transport way. So that some researchers are going. There is a drone taxi. This is one of the future idea in our global system. The drone taxi, because of the congestion of traffic, that is a traffic density. It is in the line of this one traffic one. There is a transport item is one of the drone taxi. Next one is the AR VR applications. Augmented reality adds digital elements to a live view, often by using the camera on smartphone. Virtual reality implies the complete impression. That means some before that I think already is familiar in AutoCAD. That is auto studio. That is we enter into the studio. That is the we view the all rooms and the furniture items. That is one facility is available in AutoCAD. Same, that is the AR VR. Now it is in a very interesting one. That is also in the booming. With using the text, I think you view this picture. It's a famous film. I think that is the virtual reality. It's used in the movie. There is a A.R. Murugadas directed movie Katti, I think. It's having some virtual reality ideas. Okay. Yes, I hope the session is somewhat interesting. I think. Anybody is having some questions? Any queries?
Participants, any questions?
I think I firstly told that the civil engineering area is based on our interest. There is any research area is based on our interest and also the necessity. Which one is needs the situation that we go to invention. That is the necessity is the mother of invention is one proverb. There is any questions? Or any feedbacks how the session is going on? I think somewhat bore or somewhat interesting or somewhat the maximum topics is already known or so the topics are somewhat new. I think it helps to your research works.
Sir, everyone is very interesting, sir. No
Yes.
doubt.
Sir,
No doubt,
I
sir.
think I know your name. Who is?
Sir, Dr. Gangai Mani,
Okay, sir. From MAM College?
MAM College of Engineering Technology, sir.
Okay, sir. Okay, sir. Thank you. Thank you. Hey, if you have any questions, please type in chat box also. I think that is 11 to 12:30. It's 1.5 hours.
Yes, sir.
Now I think is the time is there are a lot of things is available in for research work, but my thought is the capacity of the net facilities. Yeah.
Yes, sir.
Nowadays is a lot of meetings in the through online, some webinars and also the conferences and the lectures, guest lectures. Some people are utilizing the data are a lot of works, so I limited that the presentation is 1.5 hours. Ma'am, Sasklaman is enough or is needed?
Manigandan,
Sir, shall we conclude, sir?
Yes, sir.
conclude.
Shall we conclude?
Now we
Yes,
conclude.
shall we conclude, sir?
I call
Okay.
Deepa for deliver the vote of thanks.
Yes, sir.
Diva, are you here?
Yes, sir. Yes, sir.
Okay, you can proceed, ma'am.
Once again, good morning, all of you. This is Deepa again. It's my privilege to have been asked to propose vote of thanks. Thank you so much, first of all. I thank today's our chief guest, Dr. Jagadishwaran sir, for this informative session. Thank you so much, sir. Next,
Yes.
I thank my college management, Dr. Sasikala ma'am, and department faculty members for giving us this wonderful opportunity. Thank you so much. And finally, I thank all the participants for your active participation. Thank you so much. Thank you all.
Okay, thank you.